All right, so we are live. Hello, everyone, and welcome to another Endress+Hauser Australia online seminar. We're really excited to have you all here today. And today's topic will be digitalization in liquid analysis, how to turn data into process insights. Again, we're really excited to have you all here today. I'm just going to give you a quick overview on how to use the GoToWebinar interface if you're new to it. I'm pretty sure after 2020 and 2021, you guys are way more experienced than us. But this is just a quick recap. On the right side of your screen, there is a user interface area. You can download some additional documents we prepared for you guys, and you can also type in all your questions and comments, okay? We're gonna have some time at the end of the presentation to answer some of your questions. If your question is not answered today, we're gonna come back to you later on via email or by phone call. It's mainly up to you, all right? A short introduction about ourselves. My name is Gustavo Queiroz. I'm the industry manager responsible for the food and beverage market here in Australia, and I've been working with Endress+Hauser for nearly 11 years. I started as an intern in the service department, worked as a service engineer. After that, I moved to product management for liquid analysis. So today's topic is something that I'm really comfortable with. And just after that, I moved to the industry management role. And now I'm going to hand it over to Scott Allen. Scott, it's with you.
Thanks, Gustavo. So Scott Allen here. So I'm the industry manager for water and wastewater. Been with Endress+Hauser now for a bit over 3.5 years. I guess my history has always been involved in sales and selection instrumentation. So yeah, excited to be here today to present the topic at hand that we have today. Thank you. Over to Taylor.
Thanks, Scott. Taylor McCurdick here. I'm the industry manager for mining and oil and gas. So originally a chemical engineer. I worked with BHP for about 5 years in process engineering, and now I've been with Endress+Hauser for around 3.5 years as the industry manager. And this seminar is going to be a really good one for you guys today. I'll hand it back to Gustavo.
Awesome. Thank you, guys. So I really want to start today's webinar talking a little bit more about digitalization. And sometimes we have like a very superficial view on what digitalization actually is. The main idea here today is really to cover some of the ideas around digitalization and to show you that you don't need to have a very fancy solution to start exploring digitalization in your plant. You can actually start with something very simple with the sensor, and you can scale things up as you go, okay? Digitalization is not just the process of turning analog data into digital data. It's also how you store this information, how you can transmit this information, and how you can make everything available so you can really create process insights, and you can really improve your plant's performance, deliver improved safety, and many other stuff, okay? Before we go deep into the presentation, I want to start with a very simple question. I really want you guys' inputs on that, so I'm going to launch a poll here. And I really want to hear from you guys. What are the main challenges that you often face when you talk about liquid analysis? Okay, we have a couple of questions here, so I would be really happy if you guys can answer these. The answers that you guys have in front of you is usually the feedback we get from our customers. Okay, but we really want to understand how the audience see or perceive the main challenges around liquid analysis. If you select others, if there is any particular challenge that you often see on your daily business that is not described by the ones that I mentioned, you can also type it in the questions area. By the end of the webinar, we're going to have some time to explore some of the topics. So I'm going to give you guys 5 more seconds just for to understand what is your specific challenges. And I'm sure during this webinar, during this presentation, we're going to cover all of them, and you can have a very good idea on how you can start improving your process and how you can address all of these challenges, okay? I'm going to close the poll now, okay? It's over, and I'm going to share the results with you. Awesome. So yeah, 58% calibration know-how. Yeah. Calibration plays a very important role, especially when you talk about liquid analysis. We're going to talk about how we can improve the accuracy of your sensors with the lab approach to calibration. Lack of measurement reliability, that's the second one. That's very interesting. It's going to be the first topic we're going to cover in today's presentation, and as well with the high maintenance and short lifetime of sensors. So we're going to cover all of these topics, and I'm pretty sure that this is going to be really valuable to all of you guys. All right, so let's talk about what are the challenges in liquid analysis, but this time I want to approach the idea from a measurement perspective, okay? Any kind of instrumentation, we can talk either talking about liquid analysis or either talking about conventional instrumentation such as flow measurement, pressure, temperature, and etc. We're all dealing with electrical signals. All the sensors are transducers that will turn the variable that we're interested on into an electrical signal, and the transmitter, which is this little guy here, is going to interpret this information and convert into the variable that we're interested on. I have a very, let me just get a laser pointer. I have a very simple structure on how a liquid analysis loop works here. This is an example for a pH probe, but this applies to any other kind of sensor: conductivity, dissolved oxygen, turbidity, and etc. And as a very simple idea, we need to send this electrical signal that is generated by the sensor into the transmitter, and we're going to receive the signal, we're going to interpret, and we're going to do some math, some calculations, and we're going to give you the expected measured value. In theory, this is a very simple concept, but once we go to a practical point of view, once you have a pH probe or a conductivity sensor or any other liquid analysis sensor installed in your site, you realize this is not exactly how it happens. One particular reason about that, and this is very specific for liquid analysis, these kind of sensors, they're not just like a conventional flow device or conventional pressure devices. These sensors will need a periodic maintenance, they will need a periodic calibration, periodic cleaning to really ensure a very reliable measurement. One of the things that we often see on site is you have to remove this sensor quite often from the cable to run and execute all these verification and maintenance routines, okay? With time, especially if we have very...
Sorry, Gustavo?
Yes?
Sorry, Gustavo, Scott here. Sorry to interrupt. There's just a few hands up here saying that people can't see the shared screen, the presentation. They can only see the poll.
Oh, that's okay. I'm really sorry about it. Let me just share. Yeah. No one can see the screen. I'm really sorry. Let me see what's going on here. Stop recording. All right, I'm really sorry about that, guys. Let me see how we can do it. Taylor, can you share your screen, or any of you guys can share? I'm trying to share my screen here and it's not working really well.
Yep, I can do it. One moment.
Are we good to go? All right. Yeah, I'm really sorry about that, guys. So I'm gonna go back from the beginning. What are the main challenges in liquid analysis? Okay. I hope everyone can see the presentation now. Scott, Taylor, if you could just confirm if everyone's able to see it.
Yep, everyone can see it now. Thanks, Gus.
Awesome. Yeah, thank you, guys. Sorry about it. It's a live presentation, so yeah, these things can happen. So start explaining what are the main challenges in liquid analysis from a measurement point of view. Okay, so in front of us, we can see a very simple example on how a pH measurement loop actually works. Okay, so unlike just like any kind of instrumentation available on site, all the sensors are going to turn any kind of digital information for a pH electrode. We're going to send a voltage signal, millivolts an electrical voltage signal into the transmitter, who will interpret and will give us what is the actual pH. So from a theoretical point of view, this is something that is quite simple for us to understand. You measure an electrical signal, you send this to the transmitter, and then you're going to have your measured value. From a practical point of view, this is often not what we see on site, okay? Especially because liquid analysis sensors, they will need some sort of periodic maintenance, calibration, and cleaning. And this involves taking your sensor out of the cable and putting it back again. So if you expose, especially the electrical contacts, the metallic contacts that you have into a very high moisture or a very corrosive environment, with time, this is something that will start generating some influences on your measurement loop. I'm not sure if you guys have any kind of experience on the field, but if maybe it's something that you guys can relate. If you go to an instrument and you start shaking the cable and you can see that the measurement values start floating around, this is something that is very particular for a very good indication of oxidation and corrosion on your measuring loop. Okay, so as a result, you have unreliable data. These will lead to very high maintenance costs because you have very often need to replace your sensor and your cables, and consequently, you have a very low process performance. One of the key premises we have when we talk about process control and monitoring is that you have a reliable data coming into your transmitter and being sent to your PLC, okay? To really address this kind of problem and have a very reliable solution, Endress+Hauser created in 2004 a technology called MemoSense, okay? So we're talking about digitalization today, but this is something we've been doing for more than 17 years. And we can address and we can sort all these problems that I just mentioned to you with two different concepts. The first one is an inductive coupling between the sensor and the cable. As you can see in the photo or in the picture here, this is the sensor, this is the cable. All the information is transmitted and received from the transmitter in an inductive way. There is no metallic contacts on the sensor head or the cable. So you can have a very, very harsh condition for the sensor and the cable, and this won't affect the measuring performance at all. The second main point that we have here that can really improve how these sensors work is with the digital data transmission. So the analog signal from the measurement is actually converted into digital packages and sent to the transmitter. With this approach, we ensure that the value that the sensor is measuring at the measuring point is actually the value that you're actually seeing on your transmitter or on your display. So you either have 100% reliable data or you have nothing. Okay, so if something happens with a transmission, you receive a warning or a failure message. And more than that, we also have data storage on the sensor's head. So all the process information, all the calibration history will be saved and stored on each of the sensors. So this was the first step towards digitalization, and that's something we've been doing since 2004. Okay, and now in 2021, we're coming with a new generation of MemoSense sensors. We really want to come to the market with something that can really help our customers to really explore the digitalization field. So we are increasing our sensors performance, we're improving the data storage capabilities, and with that, we are also able to explore some new resources that can really help you improve your maintenance and your product availability, such as the load matrix. But this is something we're going to talk about in a short period of time. Okay, awesome. Just a quick short overview on how the sensor will look under a MemoSense or a digital point of view. So all the information, all the analog data is actually transformed into digital and sent in packages. So the transmitter has algorithms to identify whether some data has been lost on the way. So you can have a very, very stable and reliable transmission as well. Okay, so this is the first step when we talk about digitalization. If you really want to talk about digitalization, if it's something that is of your interest, having a smart sensor is the first step, okay? However, digitalization is just one part of the equation. You can create heaps of data, you can have a huge amount of data available, but if you don't have the expertise or the knowledge to interpret this data, you won't be able to do much. And from this point of view, we have two different approaches. We have some really knowledgeable customers who really like to explore the raw data. So this is one possibility. You can we can make all the raw data available, so you can create your own model to optimize your maintenance, optimize your process, or you can rely on the Endress+Hauser expertise. Okay, so even though we've been we launched MemoSense in 2004, we've been producing liquid analysis sensors for nearly 40 years. So this is something that we're very knowledgeable about, and we integrate all our expertise, all our knowledge, all our R&D information into what we call heartbeat technology. Heartbeat technology is really the bridge that will connect all the data generated into the sensors into valuable process insights that can really help you improve your plant availability, ensure product quality, and have really and deliver improved safety in your plant. Now I'm going to hand it over to Scott, who's going to talk a little bit more about heartbeat technology and explore further topics.
Thanks, Gus. So yeah, as Gus just said, you know, turning data into process insights, the key aspect there is actually the data. So getting data and then being able to do something with the data. So under the Endress+Hauser banner, I guess we call this heartbeat technology, which is what Gus mentioned earlier. And if you're not too familiar with this in detail, you'll find in the webinar documentation attachments there, there's some more information that's available for sure that you can have a bit of a read through and get more of an understanding. But I guess just from an overall overview perspective, there's three pillars to heartbeat technology. We have diagnostics, we have verification, and we have monitoring. So under the diagnostics pillar here, it's exactly that. It's all about diagnostics, about data, and it's about sensor health. So here is the ability for a sensor to tell us its condition. It gives us the ability to give us sort of messaging. It gives us here things like symbols around its health. Does it need some maintenance, or is there a catastrophic failure? So that's diagnostics. The next pillar here is verification. So verification is a documented in situ verification of a device. So this can be done while the device is in use and the process is running. So basically, it's a self-check of the instrument or the device. It cross-references the device's diagnostic values, and should all those diagnostic values fall within threshold values, we basically pass or fail the sensor as it's in good health or not, and then we can issue a certificate, and then that certificate can be used for compliance and quality assurance and things like this. And the last one here is monitoring. So monitoring is all about using the data available for predictive maintenance. So here, you're using the diagnostic data that's available and then using that for your maintenance regime. So that's heartbeat technology in a nutshell. So we often get asked the question, how do we maximize the accuracy of your measurement point? So one of the key aspects here is knowing the health of your sensor. So an example here is you might have a calibration maintenance regime of say 3 months as an example, which is used to keep your sensor accurate over that 3-month period, and you bring it back into line. But how do you know that in between your calibration period is the sensor actually measuring correctly and is actually in good order? So by having the data available in the sensor, we can actually get this and use this information for knowing the sensor status, and then from that get coding and messaging around its health. And then this messaging is all in line with the NAMUR NE107 standard, which is the international standard for diagnostics and self-monitoring. So it's I guess an open language that's widely used. So how do we kind of do this? So the sensor, we kind of look at the monitored internal sensor values. We also look at calibration results, so previous calibration information, and we look at the sensor history. This is things like, the age and, peak values and things like this. From there, we get the sensor health information, and then we couple that with the maintenance timer. So this would be the predefined timer that's programmed in, or it could be, a user-defined timer for maintenance. And with all this information, we get a status. Is my sensor in an okay position? And you actually see this on the transmitter or digitally as well. But we get in simple terms, we get a smiley face, or we get a sad face, and that correlates to our sensor health. And do we need to do anything there under a maintenance, a maintenance activity? So in between your calibration period of keeping a sensor accurate, this sensor status information can assist with keeping your measurement accurate at the same time as well. So another interesting area that data can be used for, sensor data can be used for, is predictive maintenance. So inbuilt within the sensors that we talked about, that we have the ability to transmit and record sensor data and diagnostics and KPIs. And this information can be transmitted to, say, control system, a DCS PLC system. It can be sent to a cloud system, for an example. And within these platforms, these platforms can actually analyze the data, and you can be looking at, you're looking at trends in your process. It could be looking at the health status of the sensor over time. And so this is the idea here, and going back to the example I mentioned before, you might have a 3-month maintenance regime, but again, do you know what's happening with the sensor in between your 3-month period? Has there been an event that's occurred that's actually potentially caused the sensor to degrade quicker than what your predefined 3-month period might have been? So in this example here, is through the data that's available in the sensors, we can actually see, was there an event? Could have been an example, high temperature, or there could have been some solids come down the line that's prematurely damaged the sensor and it's caused it to prematurely age, things like this. So by having the data available, we can actually then look at that and fitting that into your predictive maintenance regime as well. So it's quite a nice feature for sure. Let's try and get the screen to change. Oh, look, we're good now. Bit of lag there, so apologies for that. So, and I guess another interesting one here too, with going back to what Gustavo mentioned earlier here, with having all the data on the sensor, which is what he mentioned here under the MemoSense platform, I guess is the ability to help and is help process availability and also safety. And so here's an example of being able to do a calibration that's historically done in the field and then bring that to the lab. And so this is done by I guess having a sensor that you can hot swap. So rather than being in the field and then being potentially exposed to the elements, so these things could be high temperatures, it could be noise, vibration, things that could potentially be a safety issue. Other things that could be affected there, it could be things like contamination of your buffer solutions potentially. So all these things can have an effect. And so by taking the field calibration and doing it in the lab, you can overcome a lot of these issues and increase safety and process availability for sure. So I'll hand over to Taylor now, and he can cover that off a little bit further and provide some bit more information. Thanks, Taylor.
Awesome, thank you, Scott. So we found that in the poll, a lot of you guys were wondering around the optimization of calibration intervals. And that's something that I'm going to address in this component here of the seminar. Now, why is optimizing your calibration intervals actually important for your operation? Well, the thing is, if you look at the graph on the right-hand side, calibration effort is dependent on a number of factors, but really the cost to your business is also dependent on the calibration effort. So in this case, if you are calibrating your devices more than they need to be, then you're really wasting your time and your money as well by going through that calibration effort. But if you're not calibrating them enough, then that can lead to unreliable measurements, which lead to lower productivity or safety issues, which could also be a big cost to your business at the end. So it's about finding that sweet spot that you need to maintain. Now, how can you actually optimize your calibration intervals to get all your devices within that sweet spot or that optimal calibration interval? And the first one that Scott just briefly mentioned on the last slide is MemberBase Plus. So this is really turns your PC into a calibration lab. It provides traceability for different test solutions, sensors, calibrations, and measurements. And the good thing is that it uses software to monitor the MemberSense sensors, and it can keep a log inside the sensor for the entire life cycle. So that means you have timestamps matched with adjustments and explanations as well, operating hours counters, and a lot more information to help schedule calibrations. There's also reports with this software that are required for maintenance and audit trails. So it can help you to collate all the new and old calibration values, delta values, etc., that you get from MemberSense technology. Another option is that we can also use what we call the manual method. So in this case, simple Excel spreadsheet, you can manually calculate the calibration interval that's optimized for your process in Excel. Now, because you guys have joined the seminar, we've created our own Excel sheet that you can use as a basis to manually calculate that. And the good thing with MemberSense 2 technology for our devices is it has a higher amount of calibration information stored in the sensor head, which means when you export this digitally, you can be able to calculate what that optimal calibration interval is of your sensors. So you'll find that in the follow-up email that will come to you over the next couple of days, and then you can use that to manually calculate how to optimize your calibration interval. And of course, we're also here to support you if you have any questions with that process. Another good feature of MemberSense 2 is around the pH load matrix. So Gustavo briefly mentioned about that. And that is one of the new KPIs that are available with our pH probes that really a good information source to determine the question, when should I be replacing my sensor? So sensors will wear out at different rates depending on what type of process they are in. It's not necessarily a single operating hours runtime. It's also dependent on other factors such as temperature, chemical composition like extreme pHs, mechanical stress even, the temperature of the process, etc. Now, the good thing with the digitalization in MemberSense 2 is that due to all these variables are recorded now within the sensor, which means it can, by using logic in the sensor, it can determine the influence of the factors of these into the sensor and then give you a good estimate about the expected lifetime. So this is a never seen before function and very useful. Now that was one of the KPIs that are available with MemberSense 2. There's also a lot more condition monitoring KPIs that are available with MemberSense technology as well. And these can all be brought from the transmitter from each sensor. So we have an example here on the top right of the slide there, a view of what you see in the transmitter. So you've got the availability of a pH probe in this case. You've got some operating hours so that give you a good indication of how much life might be left. Number of failures that it might have. Then you have some good KPIs if you're doing condition monitoring with assets. So mean time between failures, mean time between calibrations, number of calibrations. And these type of KPIs are based on real records, which means you can bring this now into your either your asset management system or your control system, or you can also analyze it manually in your data analytics platform. And it also, as Scott mentioned before, it comes with the advanced diagnostics from NEMUA NE 107 standard, and also the transmitter will bring some additional insights for predictive maintenance requirements as well. Now you might be asking, okay, that's great, those KPIs are available, but how do I bring them and use them? Well, using digital-based communications from the transmitter, you can easily bring those KPIs into your control system. and then you can be able to use them there. And that's why we say that our liquid analytical devices are ready for IoT, as I'll discuss on the next slide around the IoT side. But this is why it is preferable to use digital communications rather than analog, because with analog, you can only bring in a limited amount of KPI information, maybe through HART communication. But if you were to have Ethernet IP, for example, or some other Ethernet-based communication, you can bring all the KPIs in at once, and then you'll have, I guess, a bit more of a rich data set to manually calculate that and also bring some additional insights. Now, I mentioned IoT, and you can also improve your business processes with IoT devices from asset management as well. So from the transmitter, you can bring it through via an edge device into a cloud solution. In this case, we can use our own Natillion cloud. And from that own Natillion cloud, there's a number of different applications that you can view on a mobile device around asset management to bring those KPIs and also the Nomura data out so that you can use it. Another way, if you don't have a field device and you need to temporarily bring it out to a cloud solution, is that you can use a HART or USB to our SMT70, which is our tablet, which has software on it, which connects to Natillion as well. And then finally as well, we can bring some analytics from install base audit as well. So there's a number of different ways to bring that KPI information into the cloud. I'm going to now hand over to Gustavo, and I think there's time for another poll.
Awesome. Thank you, Taylor. Thank you, Scott. That was a great explanation. All right, guys, I have a second poll for you guys here that I really want to know your point of view. What are the areas, what areas will benefit the most with digitalization? I'm going to give you guys 10-15 seconds to really answer these questions, okay? We have some industry real case examples that we really want to share with you today. And again, we also have another option here. So if by any reason you see a different area than the one that we just mentioned that will benefit with digitalization, please let us know. Just type your comments on the question area and we can move on. I'm going to give you guys 3 more seconds. 3, 2, 1. Awesome, thank you very much. So I'm closing the poll and now I'm going to share the results. Ooh, quality maintenance are really the top 2 areas where we can see a really good, let's say, area that we can explore digitalization, followed by production and safety. I'm going to share with you right now a couple of application examples. We're going to start with food and beverage, with the food and beverage industry. Okay. Can we move to the next slide, please? Awesome. And the first application example is pH measurement in beer bottling line. So this is a very quality oriented application. That's really good because it came really aligned to the poll answer. So one of the main challenges, if you ever had a pH measurement or any other liquid analysis, is that you really need to ensure a very high and accurate measurement in order for you to use this information in your process. This customer in specific is using a pH probe installed in a bottling line, so the accuracy of the measurement needs to be really, really high. Otherwise, you can have a huge headache if something goes wrong. And we're using here the measurement data and the calibration data to determine what is the right calibration interval for you to ensure the accuracy of your sensor, okay? And in this application, in a specific, the customer is using not only a pH probe, but he also has a complete cleaning and automatic calibration system. So we use the data to create insights on what is the right calibration time to really ensure the maximum accuracy, and we use an automatic calibration system to really ensure the maximum plant availability. And one of the cool things we have here, especially with retractable assemblies, is If you're from the food and beverage industry, you know CAP is a very, let's say, aggressive stress factor over pH probes in general. Okay, if you have a retractable assembly, you're able to retract this, the sensor during CAP, during a blunt CAP, and you can clean the sensor in a more, let's say, in a less aggressive environment, so you can really extend the lifetime of your sensors. In this case, the customer was able to increase the lifetime of his pH sensor more than 5 times compared to a fixed installation assembly. The next application is, move too fast, go back one. Yeah, dissolved oxygen in juice bottling. Measuring dissolved oxygen is something that it's a very typical challenge that we have in the food and beverage industry for beer production, soft drinks, juices, wineries, etc. You really need to ensure a very high accuracy for the measurements, and we know that sensors will wear out, especially during CAP itself. In this application example here, our customers are using the actual life consumption as one of the data that the MemoSense sensors can monitor, and they're using these as a parameter to monitor how much the sensor is offsetting or drifting with time. And we are able to determine what is the right calibration time as well to ensure a very high accuracy measurement. One of the interesting things here, just using Scott's explanation on how we can improve the plant availability and really ensure a high quality calibration. This customer in specific has 2 sensors in their plant. While one sensor is being used in the process, the other one is kept in the lab, calibrated and ready for use. Once they realize that the sensoring process reached its time of operation, they just swap. So the plant availability really increased. You don't have like the shutdown is really small, and this is a very interesting, let's say, way for you to use data to really improve your maintenance strategy. The next application is for pH measurement in raw sugar juice. And in this case, we're using the heartbeat technology. We're monitoring the sensor condition to trigger the calibration and the cleaning of the sensor. So instead of just having a cleaning of a pH probe based on a fixed amount of time, we're actually monitoring the soiling and the coating around the sensor. And once it reaches a condition that is really bad, the system can clean the sensor straight away. That's it from my side. Now I'm going to hand it over to Scott, who's going to talk a little bit more about water and wastewater applications.
Thanks, Gus. So yeah, just like Gus, I've got a couple of applications to share with you from a water and wastewater perspective. So the first one here is conductivity measurement of potable water. So it's an interesting application using our 4-electrode CLS82. I guess why you'd measure conductivity in potable water. It gives you the ability to, I guess, determine how much dissolved substance you might have in the water, chemicals, minerals, things like this that are present. So it's quite an important measurement point. So prior to MemoSense 2, I guess our older sensor here could potentially suffer from measurement issues with buildup on the face of the sensor here, and there's no real way of determining other than actually completely losing the measurement, how much buildup there was. So with the introduction of MemoSense 2 and then the additional data that's available, there's now the ability to actually measure and determine the amount of layer buildup on the sensor face here. So I guess the idea here is rather than waiting for the sensor to stop working and stop measuring and then have downtime in the process from a measurement perspective, we can actually get to the sensor under a predictive maintenance regime to do cleaning as an example. So it's quite a nice solution under MemoSense 2. Another application here we have in water wastewater is the measurement of pH. And so typically with I guess wastewater, bacteria and organisms that play a role in breaking down wastewater. They like the pH to be sort of 7 to 8, so sort of neutral to slightly alkaline. So here's an example of our CPF81. In this example here was with 4 different waste streams. But this particular customer here was looking for ways of, I guess, reducing their time in the plant. So I guess relates back to one of my earlier slides and discussion points around the safety side of things. So they're really looking to try and save their operators of being out in the elements of, exposed to gas and temperature and things like this. And then the other aspect there was also, the potential for the quality around the calibration. So the potential that their buffer solutions could be potentially contaminated in the field and things like this. So this particular customer was discussed earlier by Taylor in depth, was the ability to have laboratory calibrations, which is a really nice feature. So save this particular customer a lot of time. They were able to hot swap sensors quickly, so minimize their time in the field, and then they were able to keep up their quality in terms of the calibration accuracy, because they had a controlled environment in the lab to do their calibrations with stable temperatures and things like this. So it was quite a nice solution as well. And the last one I got to share with you here is, it's very similar to Gustavo's, but I guess from a water wastewater perspective. So, and this is in a wastewater treatment plant where we're measuring dissolved oxygen for aeration control. So one of our dissolved oxygen amperometric sensors here, our COS51. So this particular customer was really looking at a means for understanding when maintenance would be required. So rather than just making it on a time base that was to suit the sensor, they actually looked at using the data that's available in the sensor and then utilizing that and monitoring those particular diagnostics. So in this instance, I was looking at the electrolyte consumption and also the membrane cap run hours, and getting those diagnostic information back in, and then utilizing that for their maintenance regime. So there's a couple of examples, I guess, in water wastewater of visualization and using the data that's available in the sensor for greater good. So I'll hand over to Taylor now, who's got some examples for mining. Thanks, Taylor.
Thanks, Scott. Yep, so I'm going to share some examples of digitalization with liquid analytics in mining. Here's an example for a gold processing plant, so with carbon and leach tanks. So this particular example is the extension of lifetime of pH probe from 2 weeks to 4 months using Memobase Plus, and just optimizing the calibration effort and maintaining the device using a cleaning regime. And the other way they also used it is by using a handheld CML18 device for COS81E, which is for dissolved oxygen measurement. And they could move that around and use it for different yield improvement trials. And then they could easily download the information in Excel and analyze the DO and then plot that against their process conditions that they had from their control system. So the fact that using these smart sensors is much easier now to compare information from the field that you would be doing for process optimization trials. Another example that I want to show is also another mining one, and this is around cyanide destruction using a fully automated cleaning and calibration solution called the CDC90. So this was a pH application again as well, but using the digital communications that we had and also the remote control, we could extend the replacement of the probes to 4 months as well. So you can see the picture on the left shows automatic retractable assembly, pneumatically powered there. And all the KPIs from the transmitter were sent to the control system using digital communications as well. So it was a great success of getting that automated cleaning and calibration KPIs to optimize that cycle and also get some of those KPIs to the asset management system. And finally, there's an example here around remote analytical digitalization solution. So this is around monitoring key analytical components of raw water, in this case on a mine site, so pH, conductivity, chlorine, turbidity, and all incorporated into a sampling panel. And then this was connected remotely via a edge device gateway and then into a cloud visualization software so that regardless of the location of the operators on site, they could have a look at the analytical data from their mobile device and be able to make operational actions from that. So you can see in the schematic that it was this panel solution to a gateway into cloud, and then from the cloud it can go from that information can be incorporated to the PC or their own mobile device as well. So as you've had a look at some of the examples today and with the new MemoSense 2 technology for digitalization and liquid analytics, you can see we have a very wide range of IoT ready devices that have this technology incorporated into it. And we've also recently expanded our EX capabilities with the different transmitters. So the Liquid Line Slim one there with the Bluetooth capability, and also our handheld CML18 with Bluetooth. So you can see that they're IoT ready and ready for your applications as well. So what we're going to do now, we've got a few minutes still to answer a few questions. I can see there's a few questions coming in. If you haven't had an opportunity yet, type in the questions into the chat, the question section on the right-hand side, and we'll address them now. If we don't manage to get through all of them in this session, we will get back to you via email afterwards, and we'll get to answer those questions. Also, if you are just upon the leaving the seminar, if you could complete our survey, that would be very much appreciated, just to see how we're going with the seminar and also any other topics that you want to see addressed in the future. All right, so I'll go straight into the questions now. We've got a question from Russell. He's just asking if there's inductive cables suited for different types of sensors. So I guess the MemoSense cable, is it okay to use between pH or conductivity sensor? Scott, this is one for you.
Thanks, Taylor. Yes, that's certainly possible. So the inductive coupling there from a MemoSense, it's not just for one particular type of sensor. So there's it's actually quite the full portfolio there. So you've got pH, conductivity, dissolved oxygen. So basically, wherever you see the little blue inductive coupling is where you can use MemoSense and have the full value of being able to pull that data through. So thanks for the question.
All right, thanks, Scott. All right, so got this one for Gustavo. Is the software and system monitoring CGMP compliant or validated? That one's from Mark.
Mark, yeah, good question, Mark. It is. If you're talking about MemoBase Pro, we have full good manufacturing practices compliance. So you can create standard calibration and verification routines, and you can keep all the traceability into the software as well. So yes.
Excellent, thank you. We've got another question for you, Gustavo. I think it's a question around I'm just trying to read it here. This is from Gary. He's asking, can the device be programmed to only transmit changes in readings, so date, time, and new reading? I guess that might be for a remote application, but do you have any insights on that?
The measurement itself will be held in a constant way. What we can do is the transmitters have logbooks available, so you can keep track and you can monitor, you can set some specific alarms. And if you combine the transmitter with an edge devices in a cloud solution environment, you can trigger, for example, if there is a change higher than a specific value, you can get a notification. Yeah, it's possible. It's possible.
Okay, thank you. Got a question around heartbeat verification, if it can be triggered remotely via an edge device. Does anyone want to tackle that one? Or I can take that.
That's a good question. I have to be aware. I have to confirm this information. but the edge devices, from a security point of view, the data is only sent into the cloud. We have a couple of limitations in what we can actually write into the device. That's a really good question. I don't know how to answer now, but we can definitely come back to you, Duraj.
Yeah, we'll come back to you and ask you a few more questions around what your topography is for that and what you have existing, and then we'll see to find a solution. That's a good one. We've got a question from Brendan. He asks, can the heartbeat technology be used with analog sensors or just with MemoSense sensors, the digital ones? Scott?
So this is it's a good question, Brendan. Yeah, definitely. So it is actually, heartbeat's only suited from a liquid analysis perspective for the MemoSense sensors. So again, wherever you see MemoSense, and it goes back to, I guess, Gustavo's first couple of slides there. If you remember there, Brendan, it was in relation to where we convert analog signal into digital, and it's really getting that digital data. So unfortunately, it's only just for the MemoSense offering and not analog sensors. Yeah.
All right, thank you. Gustavo, one for you. Do we have a sensor that can monitor refractive index?
Good question. The answer is no, not in our liquid analysis offering. From an Endress+Hauser point of view, we don't have refractive index measurement. What we do have, usually refractive index is usually used to measure density or concentration, such as bricks. But we do have different technologies that are designed for this kind of application based on density or ultrasound, okay? So two different approaches, but at the end goal, it's the final measurement value is something we can explore with you.
Awesome, thanks, Gustavo. And I think I have the last question for today. This one's from David. This might be for you, Gustavo, as well. He's asking you around IO-Link. Is it supported for liquid analytical probes?
Really good question. The MemoSense technology, we don't have our transmitters with MemoSense technology, they do not support IO-Link, okay? What we do have is we are launching a new conductivity sensor with IO-Link later this year or beginning of 2022. So our IO-Link offering is really designed for fit for purpose applications. Yeah, but at the moment, IO-Link for the current generation of liquid analysis, it's not available. Okay?
Okay, excellent. Thanks, Gustavo, and thanks, Scott, for your time today. I think we had a great number of questions there and a great seminar as well. Reminder to fill in the survey at the end to ask any further questions. Otherwise, feel free, and then look out for the follow-up email where we'll send you that calibration interval calculator. Otherwise, that's it from us at the moment.
Thank you, everyone. Have a good one.
Thanks, everyone.